This is a little addendum to the level curves video. What I wanted to do in that video, but I couldn't because of the slow computer I was using to do the math. I wanted to rotate the figure around that I had open in the math program. And so I wanted to do that and also briefly show you the program that I'm using here. It's called Maxima. It's free. I'll provide a download link on berkeyacademy.com for Maxima Portable. And what I'm going to do here is define, and I'll also provide the download for this little file, so you can play with these level curves if you want to and make some different graphs. In this first line, I'm just defining the function we're graphing, q equals x to the 1/3 times y to the 2/3. And here I'm going to plot the 3D surface, and I'll turn it around so we can kind of smoothly see what this shape looks like. So again, here's the x-axis on the right-hand side and the y-axis on the left, and z is going up. So as we saw in that figure, as we use more say labor and more capital, we're heading up this hill and we're producing more output. Now, the level curve that we graphed in that video is the yellow one up here, I believe. And if we turn this on its edge, this is what I wanted to do in that video, you can see the points that are traced out by each of these level curves for different numbers of units of output. And you can verify that this is the one that we drew as the yellow one because it goes through x equals 4 and y equals 4, and that gives us 4 units of output. And we'll be using these kinds of curves a lot in this class, and so it's good to get a feeling for what they mean and how they work. Let me turn it back up here a little bit. I also had a suggestion from a viewer who wanted to look at a plane cutting through this figure at y equals 4. And so we're going to do that in just a minute. But let's just get a nice look at this figure from all sides. Now we're looking up underneath the shape, and now we're back looking at the top. And let's look at it from the side here. Here we're looking at the y-axis along the bottom, and it looks like as we go up, we climb pretty steeply up these level curves. For example, here, what we're doing is we're assuming that we're using 8 units of y. And as we go this direction, we are using more and more x. So as we use more x, we're climbing steeper and steeper and steeper and steeper quickly, and we're building more and more units. And we're holding y fixed at 8. Similarly, if I turn it around the other way and say, look at x equals 8, and we head up, we're going from 0 units of x and using more units of x as we travel up, 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 up that curve. Now, another way, and again, this is, I think, a helpful suggestion from a Berkey Academy viewer. He wanted to see what would it look like if we drew a plane through this curve at 4 units. So we can really focus on what's going on there. So this plane, this red plane I have here, is cutting through this curve at z equals 4. And you can see that yellow level curve right there, just barely, where that red plane intersects. And we can also look at this curve from underneath, and we can see that plane cutting through there. And so that's really what a level curve does. It fixes our attention at one value for the output variable in this case, if we're thinking about this as being the quantity of output. And we trace along, let's look at this from the top. We trace along, just like we did in the video, all the different values along this yellow level curve, all the different values that allow us to produce that 4 units of output there. So hopefully this visualization gives you a little bit more information, a little bit different views of what's going on in this curve.